Hello, everyone. Good morning. And this is John Michael Perez. And today I'm going to be delivering to you my part in our report in factor analysis, which is the step by step procedure here on how to solve factor analysis in SPSS. So, before that, actually, in this video, we'll take a look at how to run factor analysis, or more specifically, we'll be running the principal components analysis in SPSS. And as we begin here, it's important to note that because it gets confusing sometimes, that factor analysis is actually an umbrella term where the whole subject area is known as factor analysis. But within that subject, there's two types of main uh, analysis that are being run. The first type is called principal components analysis, and that's what we'll be running today. And it's actually the most common fact. The yeah, this the other type actually is the common factor analysis, but we don't see that most of the time. We see here the principal components analysis, and that's what we'll be running today. So if you look here in the screen, you see here that we have five variables. We have SWLS1, 2, 3, 4, and 5, and these variables are they come from the items of the satisfaction with life scale published by Diener et al. And so basically, what people do is that they take these five items and they respond to five items, where SLWS1 is in most ways my life is close to my ideal, and then we have the conditions of my life are excellent. I'm satisfied with my life. So far, I've gotten the important things I want in life. And then number five is if I could live my life over, I would change almost nothing. So, what happens is that people respond to these five questions or items, and each questions they have the following responses, which I've already input here into SPSS. We have here the value labels: strongly agree, strongly disagree, all the way through, yeah, strongly agree, which give us a 1 through 7 point scale, or a 7 point Likert scale. So what we want to do here in our principal components analysis is we want to go ahead and analyze these five variables here, or items, and see if we can reduce these five variables or items into one or few components or factors which explain the relationship among the variables. So let's go ahead and start by running a correlation matrix, and what we'll do here is we'll go to our analyze. Okay, please wait for a while. Okay, here, analyze. Okay, and then correlate. Yeah, and then bivariate, and then we'll move on to these five variables over. So you will see that we move one here. Oh yeah, all of them, and then yeah, we click OK, and here we notice we get the correlation matrix of SWLS1 through SWLS5. So these are all the intercorrelations that we have here. And if we look at this off diagonal, where these ones here are the diagonal, and they're just one because one of these variables is correlated with itself, so that's always 1.0. And then the off diagonal here represents the correlations of the items with one another. So for example, this 0.531 here, notice it says in SPSS that the correlation is significant at 0.01 level, two-tailed. So this is where the correlation between SWS2 and SLWS1. So all of this in this triangle here indicate the correlation between the different variables or items on the satisfaction with life scale. And what we want to see here in factor analysis, which we are about to run, is that these variables are correlated with one another, and at a minimum significantly so. Because what factor analysis or principal component analysis does is that it analyzes the correlation or relationships between our variables, and basically we try to determine a smaller number of variables that can explain these whole correlations. So notice here that we're starting with five variables, SWLS1 through 5, and hopefully this analysis, when we run our factor analysis, will come out with one component that does a good job of explaining all the correlations here. And one of the key points of factor analysis actually is the data reduction technique. So what it means is we can enter a number of variables, like say for example 5 for this, and or sometimes you could go for 20 or 50 or whatever you have with you. And we hope to reduce these variables down to just a few. Most of the time between 1 and around 5 or 6, most of the solutions that I see. So now in this case, since we have five variables, we really want to reduce this down to one or two at most, but one would be good in this case. So that's really a key point of factor analysis. Basically, we take a number of variables and then we try to explain the correlation between those variables through a smaller number of factors or components. And by doing that, what we do is we get more, generalized solution or a solution that explains these variables or relationships. And there's a lot of applications of factor analysis actually, but one of the primary ones is that when you're analyzing scales or items on a scale, and you want to see that scale turns out also how many dimensions or factors doesn't it have to it, like Likert scale for example. In our example gani, 'di ba? 7-point Likert scale siya, guys, ang data. So, first of all, notice that name here, dimension reduction, and the key here is a reduction. We're trying to reduce a certain number of variables or items to a smaller number of factors or components, and we can refer to these as dimensions. So if we have one factor that's a one-dimensional solution, two factor is two-dimensional solution, and so on. So let's go ahead and select factor, and then what we have here is move all our variables over to the right. Go ahead and select descriptives, and we'll select univariate descriptive to get some univariate descriptive stat on each of our variable, and also select KMO and Bartlett's test of sphericity. Then we'll click continue, and then next as we go to extraction, and notice here by default that the method is principal components and that I had mentioned that we're going to run today, so that's good. So that's it already. We want to leave that selected, okay? So if you are looking for an alternative procedure, you can find number of them. But now we're just going to principals components. So okay, and then we'll go ahead and leave these defaults. We have annotated factor here, solution displayed, and then I also want to display a scree plot. So malantakot a scree plot later. It will tell us about more in a few minutes, okay? Um, this let's leave this extraction as well ni ato hindi kita guys mangtandog ka mga bagay-bagay guys, okay? So aton di nga eigenvalue is greater than 1, okay? So click continue. Okay, next is rotations, so let's go ahead and look at that. Now I'll go select here Varimax kay amo ni siya ang akon nga nakita sa process. But notice here we have five different options as well. The first thing is to note that there's two key types of rotation. These are orthogonal rotation and there are oblique rotation. Now, orthogonal rotation means that your factors or components, if there's more than one, if there's two or more factor or components, they will be uncorrelated. In fact, that rotational solution forces them to be uncorrelated. So now oblique, on the other hand, they're rotated in such a way that they're allowed to be correlated. So you'll get solutions where factors typically will be correlated to some degree, and then but the oblique rotation allows for correlation. So now of these rotation procedures in SPSS, Varimax, Quartimax, and Equamax are all different types of orthogonal or uncorrelated rotation, whereas direct oblimean and Promax are in the iPhone but are oblique or correlated rotations. So makita niyo na siya, nakman ni sila, direct oblimean, kag Promax, hindi siya iPhone again. So, okay, so we'll go select Varimax in this case. Okay, and then click continue here, and then that looks good. So go ahead and click OK. And then here we have our analysis. And our first table we'll look at here is the KMO and Bartlett's test. So this is sometimes reported, so I want to be sure that you understand what it is here. Bartlett's test, the sphericity, That's what we're going to be focusing on. And Bartlett's test of sphericity, we notice here that first of all, it is significant. It's less than 0.05, and it approximates a chi-square distribution, so we can consider it chi-square distributed. And what this is testing is it's actually testing whether this correlation matrix here are variables. So item 1 with 2, item 1 and 3, 2 and 3, and so on. So this entire triangle, are these variables, are they correlated or significantly different than zero? But unlike the correlation matrix, it doesn't test each individual correlation separately. But what it does is in one overall test, it assesses whether these 10 correlations taken as a group, or do they significantly differ from zero, and more precisely, for those who are familiar with matrix algebra, kunyari, genius ako sa math, it's testing whether this correlation matrix is